A pottery chuck is a specialized support used to hold ceramic pieces, especially those with narrow necks, delicate rims, or irregular shapes. The piece is held upside down for trimming on the pottery wheel. The chuck is centered on the wheel by eye and may be held in place with clay at the base. It is common to throw and fire your own chucks, which work well, but surface irregularity on the inner wall may distort the pot, and it is difficult to centralize on the wheel. This is the completed system, which can handle chucks up to 240 millimeters diameter. That is just the limit of my 3D printer, but printers with larger beds are available. The maximum neck length would be about 250 millimeters, again set by the printer limits. So this was the first prototype that I built from the shape and diameter parameters. It came out quite well and I was happy with it, but obviously there is a seam inside which needs to be sanded, and I kept on looking at that and thinking if there was a better way to do this. The other thing is this is designed to sit on the wheel and held in place with clay at the base. It also needs to be centered manually. So then I started developing the idea, and printing it in 2 halves makes it easier and quicker as well. This gives me a bit more flexibility, and I can also join 2 different size pieces together. This was the main holder, and inside that goes a sleeve which locks into place to prevent the pot rotating. You need to hold that in place when you lift the pot out, so then there was a fixing ring that went on the top secured by several screws. So the next stage was to develop a liner that could actually go inside the clamp and then give you a completely smooth internal surface. The liner is just a different color to show how it actually fits. There is a seam on the carrier but not on the insert. So the insert is created in vase mode, which prints continuously in a spiral motion. This method can only produce an item that is as wide as the printer nozzle. In this case, the liner is 0.4 millimeters thick. Anything thicker would require the printer head to raise up and move to the next layer, which causes a step. These steps are on each layer, hence the effect of a seam. So while I was working on this, I was also thinking about how to clamp the chuck down on the wheel and try and get some method in there for shifting this to the center of the wheel. I needed some attachment points on the chuck, which will be explained later. The problem here was that you can't print this whole thing in one piece without using lots of supports, because when the printer comes to this area, there's nothing underneath, it's all overhang. We need supports coming up underneath, and these make life difficult. So again, this is printed in 2 parts to make it easier, and then join them together with a few screws, it's no problem. We add a liner inside, there's one already glued in place. The liner is quite thin, but as it is in direct contact and glued to the chuck, it should be durable. The liners can be printed to fit any profile. So this is the largest version I've done so far. 200 millimeters diameter on the top and then 175 millimeters diameter on the bottom. About 200 millimeters high. It will take quite a large pot with a long neck. If there is any damage done to the liner, then only the 1/2 needs reprinting, so that saves time, effort and money as well. For a pot with a really long neck, beyond the printer's capability, I could make an extension tube to fit between the 2 chucks. Naturally, 3D printing has the advantage of producing perfect circles, so the chuck is always concentric. It is also possible to create shapes that would be extremely difficult using normal pottery techniques. To complement the chucks, I developed a fairly simple jig that ensures the chuck is always centered on the wheel, but easy to remove when not needed. This wheel is 350 millimeters diameter and 30 millimeters deep at the rim. I have printed components to fit onto a 12-inch wheel as well. Other sizes can easily be supported. Place a chuck in the center of the wheel. Any chuck will do, as we are just assembling the initial frame. Place the clamp ring on the wheel. If the clamp wheel is not pre-assembled, then secure the rings as shown. Do not over-tighten. Each chuck has a set of clamps which connect to the ring. The clamps drop in place over the lower chuck and locate into a slot on the ring. These will fit easily without force. The clamps are secured to the ring using thumb screws. The chuck is now locked to the ring and will not move. The spring clamps may already be fitted to the arms. If not, then assemble as shown. It's important to leave about 10 mm gap between the clamp and arm for the next step. We now fit the centering arms which slide in place under the ring. Each centering arm is fixed to the ring using a 3 mm screw. However, these fixings are not really designed to be removed, and the threaded holes will wear after a few operations and no longer work. If you have more than one size of wheel, then an additional ring, arms and spring clamps will be needed. Next are the spring clamps that fit to the centering arms. These clamps allow the whole assembly to be securely mounted to the wheel. We previously left a gap when assembling the clam and arm. The spring clamps need to fit flush to the wheel so the gap is filled with spacers. In this example, the gap requires an orange spacer and a red spacer. Tighten the retaining screws on all 3 clamps. The clamp should sit flush with the wheel edge. I have assumed that the wheel is accurate and also sits on the drive shaft without an offset. If the wheel does not run true, then the whole chuck assembly can be shifted by adding or subtracting spacers from the arms. This moves the chuck center relative to the wheel. If there is an offset, then mark the position of arm number 1 and make the adjustments. This will be the reference point when replacing the whole system after throwing a new pot. To complete the installation, the spring clamps are engaged. Press down on the thumb wheel to disengage. Continue pushing the thumb wheel down against the spring and twist under the wheel. Release and the clamp will lock into position. This ensures that the clamp cannot move during operation. The ring, arms and locking clamps are common to all chuck sizes. To replace a chuck, the chuck clamp arms are removed. New chuck positioned. Chuck arms fitted and secured with the chuck screws. This should take less than a minute. The whole assembly can be removed in one piece by unlocking the spring clamps. It would probably be safer to remove the chuck and brackets first. Lift the ring assembly vertically to reduce stress on the clamps. I have produced one complete system for testing in a real pottery environment and will be interested to see how it performs. One of the downsides with 3D printing is the printing time, and I think a full set of parts may take 2 days. This rules out mass production for me, but not for someone with a print farm. I am happy to work with anyone interested in taking this forward.